the 7th spacewalk in the career of Shane Kimbrough, who has accrued a total of 39 hours even on 6 previous spacewalks. He will be wearing a helmet camera bearing the number 22 during the course of today's spacewalk, helmet camera number 22. And this will be the 3rd spacewalk in the career of Thomas Pesquet, a former Air France pilot who is with the European Space Agency making his 2nd flight into space. His 2 previous spacewalks accrued a total of 12 hours and 32 minutes of spacewalking time. He'll be wearing a helmet camera bearing the number 20 during today's spacewalk. The 2 crew members will also be wearing HD helmet cameras, as well as the standard helmet cameras that you have become familiar with over the course of spacewalking coverage. That will provide more detailed looks from the crew members' perspective as they conduct all of their activities in support of today's spacewalk. The Orbit 1 team of flight controllers is on console at this hour as you look at an overhead view looking at Shane Kimbrough, who is again on the left side of the Quest Airlock's equipment lock section, just over the shoulder of Thomas Pesquet, who's on the right side of your screen, lower right-hand side of your screen. The dispersion of nitrogen out of their bloodstreams to prevent any condition known as the bends or decompression sickness from occurring when they step out into the vacuum of space. Today's spacewalk is scheduled to begin about an hour and a half from now at 7 a.m. Central Time, 8 a.m. Eastern Time. A U.S.-based spacewalk out of the Quest airlock is measured at the beginning from the time that the crew switches their suits to internal battery power until the time of repressurization when they're back inside the airlock at the completion of an EVA. And the first set of solar arrays that were delivered to the International Space Station aboard the Space Shuttle Endeavour in December of 2000 on the STS-97 mission that was commanded by former astronaut Brent Jett. In the forthcoming months, 2 additional pairs of IROSA solar arrays will be delivered. The next pair will be installed on the P4 and S4 starboard 4 truss of the station, and the final pair will be deployed on the S or starboard 6 truss and the starboard 4 truss. 6 of the 8 power channels for the International Space Station will have their power augmented by these new solar arrays to provide an additional 20 kilowatts of electricity, eventually totaling some 120 kilowatts in all of augmented power during orbital daytime. In addition, the remaining uncovered solar array pair and partially uncovered original arrays will continue to generate some 95 kilowatts of power for a total of some 215 kilowatts of power for the rest of the lifetime of the International Space Station. This will accommodate more modules to be launched to the International Outpost and to provide the augmented power to the 6 power channels that have, through normal wear and tear over more than 2 decades of use, have seen some degradation in power output. This will bring the International Space Station back to an even more robust power capability than the original arrays were designed to provide. Kimbrough and Pesquet, interestingly enough, conducted a pair of spacewalks together several years ago during Expedition 50, the first on January 13th, 2017, where they worked on the most recently completed set of battery replacements, where nickel-hydrogen batteries were replaced by lithium-ion batteries on the International Space Station. They also worked a couple of months later during Expedition 50, going outside together on March 24th, 2017, to lubricate the latching end effector at the end of the Canadarm2 and to prepare the Zenith port on the Harmony module of the International International Space Station for the installation later on of the second of the two international docking adapters that are now used for commercial crew vehicles arriving at the International Space Station. So they are familiar with each other. They have their choreography pat, and they're ready to go outside once again to begin their third spacewalk together, the 239th in the history of space station assembly, maintenance, and upgrades. The clock's up on the wall here in Mission Control, counting backward for a go for the depressurization of the Quest airlock. Before long, you see in this view Mark Vande Hei, NASA astronaut, on the right side of your screen. Megan MacArthur's on the left. You'll see them attach jet-powered backpacks to the two spacewalkers' extravehicular mobility units. They're called SAFERs. That's the acronym for Simplified Aid for EVA Rescue. Those are the jet-powered backpacks that would be used in the highly unlikely event either of the crew members would become detached from the tethers that hold them in place as they go about their work on the outside of the Quest airlock. They then, one by one, will be moved into the outermost compartment of the two-compartment Quest airlock called the crew lock that you see Vande Hei at the threshold of. That then will be followed by the closing of that hatch. The two spacewalkers will hook themselves up to umbilicals inside the crew lock and await the green light while the depressurization of the crew lock section brings it down to vacuum as the precursor to their placing their suits on battery power to mark the official start of today's spacewalk. Today's spacewalk is the first of two in the next 4 days by Pesquet and Kimbrough. They'll go outside once again on Sunday, on Father's Day, to install the second of the two IROSA solar arrays that arrived on the SpaceX Cargo Dragon vehicle about a week and a half ago. This first of the two IROSA arrays will be installed to service the so-called 2B channel of the P6 truss of the International Space Station. The work that they will conduct on Sunday will be the installation of the 4B power channel arrays. And you can see in this graphic how the ISS rollout solar array, these new arrays look like when they're deployed adjacent to the legacy arrays, which are about twice as long.
At the start of the EVA, EV1, Thomas Pesquet, comes out first, followed by EV2, Shane Kimbrough. Thomas translates up to the front face of the truss and translates outboard. Thomas is setting up what we refer to as safety tether anchors. At this point, he'll drop the anchor point for both he and Shane. Shane will be retrieving an articulating portable foot restraint and putting his stowage bag onto it for translation outboard. Thomas makes his way out to the carrier that has the solar arrays stowed on it. Shane follows along the truss and meets Thomas at the carrier. The crew drops off pistol grip tools and bags in preparation for releasing IROSA from the carrier. Shane makes his way outboard onto the P6 truss element and stows the articulating portable foot restraint that he'll be using later on in the EVA. Continues translating outboard to the very end of the truss and stows his stowage bag. Thomas prepares the IROSA by releasing the first hinge bolt and stowing his pistol grip tool. Thomas makes his way outboard and releases an anti-rotation device which keeps the primary bolt locked in place during launch loads. Thomas retrieves a handling aid for IROSA. We refer to this as a scoop. Meanwhile, Shane retrieves a crew lock bag and installs it on the lower support truss of the mod kit. He retrieves another scoop, another handling aid, and installs it on the mounting bracket of the mod kit. Shane retrieves one of the two sets of cables and pre-positions them for future installation. Shane retrieves his pistol grip tool and makes his way back inboard to join Thomas. Thomas prepares the release bolts down to the last few turns. Thomas installs one of the handling aids and makes his way back around Irosa. He changes out his pistol grip tool and makes his way down to the crew and equipment translation aid, or CETA cart, and retrieves the foot restraint that he'll use on the end of the arm for his work with Irosa. He installs the foot restraint at the end of the arm, puts it in the right position, and ingresses the arm. The arm then flies him into position to drive 2 bolts that are on the boom deployment system. Once these bolts have been released, the booms can be moved outboard, and this will help with the release of the solar array when it's eventually deployed. Thomas drives 2 of the outboard launch restraint bolts that hold the tube in place, and the arm maneuvers him for release of Irosa from the carrier. Meanwhile, Shane makes his way over to the carrier and gets into position for release. Shane drives the last few turns on the release bolts, and now the Irosa solar array has been released from the flight support equipment. He installs a handling aid, and Thomas is able to slide Irosa off of the carrier and remove it. Meanwhile, Shane is keeping an eye on the whole system to make sure that Irosa does not come into contact with the RMS grapple fixture, and away Thomas goes with Irosa. Meanwhile, Shane gets off of the carrier and translates outboard. He'll stow Thomas' safety tether hook in preparation for when Thomas comes off of the arm, and he'll continue his path outboard. He stows his pistol grip tool, makes his way to his foot restraint, and ingresses. While he's getting into his foot restraint, Thomas is continuing his path, holding on to Irosa while the arm flies him as far outboard as it can reach. He hands off the Irosa to Shane. They swap tethers. Shane has control of Irosa and is left holding it, while Thomas goes back to his egress position. He gets out of the arm, changes his safety tether, and makes his way back to where Shane is holding Irosa. He then rotates Shane into position so that Irosa is handed off to the next point. Thomas ingresses his foot restraint and receives Irosa. Shane egresses his foot restraint, moves outboard, and gets into position to help Thomas install Irosa onto its final location on the mod kit. One of the 2 handling aids is removed before installing onto this mounting bracket. The 2 crew members work together to align it and put it into a soft capture feature. Once it's installed, the other handling aid is removed, the final hinge restraint bolt is loosened, and Irosa is now able to rotate into its fully deployed, fully extended position. The 2 crew members work together to swing it into the single tube. Once it is in position, Shane stows the 2 handling aids. Thomas gets into position to drive the hinge bolts. These 2 bolts hold the 2 halves of the Irosa solar array into a single tube. These bolts are delicate pins, so the final torque to get them into position is done with a hand tool so that we don't over torque those bolts. Once that's in place, there are 8 mounting bolts that hold all of the Irosa solar array onto the mounting bracket. Thomas will drive the first 4, followed by Shane driving the second set of 4. Shane and Thomas will work together to install the electrical cables that hook up to Irosa. One set goes to the right side and the other set goes to the left side, and they are finally hooked up in place on the legacy solar arrays. That's done during eclipse. After those cables are installed, the crew gets into position to drive the final 2 bolts that are holding Irosa in the pre-deployed position. Once these 2 bolts have been driven, Irosa is free to extend itself into its deployed position. After the crew's verified that the solar array is in the right position and it's fully deployed, they drive 2 tensioning bolts. This allows the sail to be tensioned into its final configuration. Once Irosa has been fully deployed, there are some checkout steps that are performed to make sure that everything is hooked up correctly, and the crew cleans up the worksite. They retrieve the handling aids and the pistol grip tools, and they prepare for the second EVA in the series. To do this, they take their foot restraints and move them to the other side of the P6 truss structure. This will be the work site for the second EVA. Each crew member has their own foot restraint, and they'll move them to the other side. The crew repositions the stowage bag that's holding the other set of cables to the other side of the truss, pre-positions it for the next EVA. The crew will do an inventory of all their tools and their hardware, and they'll start their path back to the airlock. On their way back, they'll stop at the carrier, pick up the last crew lock bag and the last pistol grip tool, and make their way inboard. When both crew members are back at the airlock, they'll retrieve a foot restraint that has been causing us problems and bring it inside the airlock to inspect. Shane will enter the airlock, followed by Thomas, and that ends the first EVA.
And the electrical systems officer here in Mission Control has indicated that if all goes as planned, we should get some indication that the newly deployed ISS rollout solar array is generating the proper amount of power either before or during the time frame that the crew is re-entering the Quest airlock near the end of today's spacewalk. Once again, as you saw in the animation, IROSA, you'll be hearing that acronym frequently throughout the course of our coverage today. IROSA standing for ISS Rollout Solar Array. It will be positioned in front of the legacy solar arrays, or the older solar arrays on the P6 truss of the station. It attaches to the existing beta gimbal assembly that permits it the use of existing sun tracking, power distribution, and the power distribution to the proper channel. In this case, the first array to be installed and deployed today will service the so-called 2B power channel, the first of 6 power channels to be augmented during the course of these IROSA installation and deployment activities. These arrays will shadow approximately 2/3 of the legacy arrays. We're about 37 minutes away from beginning the depressurization of the crew lock section of the Quest airlock. Over the course of the next half hour, the simplified aid for EVA rescue backpacks will be affixed to the back of the spacesuits for Pesquet and Kimbrough, and they'll be moved into the Quest airlock. The hatch will then be closed, and they'll be isolated from the rest of the crew members on the international outpost for the remainder of the day. At this hour, the International Space Station is flying 258 statute miles over the Ukraine, south of Kiev, moving from northwest to southeast in an orbit inclined 51.6 degrees to either side of the equator. Some of the timing of today's spacewalk is measured to be conducted during orbital nighttime, particularly the actual hookup of power connectors for the new solar arrays, so they're not hot, quote unquote, at the time that they're acquiring electrical power from the sun during an orbital daylight pass. So there will be times in which the crew, if they're running slightly ahead in the timeline, will be asked to simply stop so that the timing of certain tasks to be conducted deliberately during an orbital nighttime times out correctly to meet the particular technical requirements for the installation and deployment of the ISS rollout solar arrays. Inside the equipment lock section of the Quest airlock, Megan MacArthur and Mark Vandehei are beginning work to affix the first of the simplified aid for EVA rescue or safer backpacks to Thomas Pesquet's spacesuit. Shane Kimbrough will be next up to have his safer unit installed. Again, those jet-powered backpacks are designed to provide the capability, if necessary, in the unlikely possibility that a crew member would become detached or untethered during the course of the spacewalk, they could propel themselves back to the structure of the International Space Station and into safety. This is Mission Control Houston. In the field of view, in the foreground is Space Station Commander Aki Hoshide from the Japan Aerospace Exploration Agency, as Megan MacArthur and Mark Vandehei are finalizing the attachment of the jet-powered backpack called the Safer to Thomas Pesquet's spacesuit. Again, you see the red stripes on his legs. That's indicative of his designation as extravehicular crew member number 1, or EV1. He'll be first out of the crew lock section of the Quest airlock once the hatch is open and the suits are placed on internal battery power to begin the official start of today's excursion by him and Shane Kimbrough, the NASA flight engineer, who will spend 6.5 to 7 hours out in the void of space today, attaching the first of a half dozen ISS rollout solar arrays to augment the power capability of the International Space Station. Thomas Pesquet is now inside the crew lock section of the Quest airlock. Shane Kimbrough now will be assisted in the donning of his Safer jet-powered backpack before being moved across the threshold into the crew lock section to join Pesquet. In the equipment lock section of the Quest airlock, a wealth of spacewalking experience abounds. Mark Vandehei with 4 spacewalks to his credit in his career. Aki Hoshide, with his back to the camera, has conducted 3 spacewalks before. Megan MacArthur's previous flight into space, of course, was part of the crew for the final servicing mission of the Hubble Space Telescope. She operated the shuttle's robotic arm to capture and later deploy the Hubble. She will be operating the Canadarm2, the space station's robotic arm, today to transport Thomas Pesquet around with the ISS rollout solar array to the work site at the far port section of the International Space Station, where he and Shane Kimbrough will work in tandem to install that solar array to a so-called mod kit that was hooked up on a previous spacewalk, and then, of course, to loosen bolts and other mechanisms to permit the deployment of that array. This is Mission Control Houston. You are looking live inside the equipment lock section of the Quest airlock of the International Space Station. You're looking at NASA flight engineer Shane Kimbrough and his extravehicular mobility unit. His crewmate, Megan MacArthur and Mark Vandehei, are across the threshold that separates the equipment lock from the crew lock section of Quest. Thomas Pesquet of the European Space Agency is already inside the crew lock. Shane Kimbrough soon to be moved inside to join his spacewalking colleague for today, as we are about 15 minutes away from the start of the depressurization of the crew lock section of Quest. That will be the precursor for the start of today's spacewalk by Pesquet and Kimbrough to install the first of a half dozen new solar arrays to augment the power system of the International Space Station. Today's work to be conducted on the far left or port truss of the station at the P6 truss, the first truss element of the station to carry a solar array that was launched aboard the Space Shuttle Endeavour in December 2000 on the STS-97 mission. This is Mission Control Houston. Both Thomas Pesquet and Shane Kimbrough now inside the crew lock section of the Quest airlock. Aki Hoshide in the foreground, assisted by Mark Vandehei, now beginning to close the hatch. That will isolate the two spacewalkers for today. We're about 7 minutes away for a go for the depressurization of the crew lock section that will be done in a two-step fashion. While we have a moment, let's replay for you the 7-minute animation narrated by the lead spacewalk officer, Keith Johnson, who will outline all of the tasks that face Pesquet and Kimbrough in today's spacewalk.